if as you sit down, I could pose a first question, and then we can open it up to the audience. So we've seen the differentness in terms of texture, context, materials, and engineering of these towers, and their exceptional differentness from the typical New York residential block. But maybe we could speak a little bit to the different economics of slenderness compared to more conventional forms and floor plates. Does anyone want to talk about that?
Well, the economics, I think there are a few issues that we all had to deal with here that was mentioned many times, but I won't mention it again. Is the use of very high-strength concrete, 12,000 PSI, which is unusual for residential buildings. That has a cost. You know, you saw the scale of the structure that goes into the foundations. That's part of the cost. The limited site area, which makes it very difficult to work. The interesting thing that I saw as One Madison Park was going up was that staging was incredibly complex. The floors were only 3,300 square feet, and that included the shear walls, that included the elevator shafts and stairs. And to stage the work in a way that made sense, you know, certainly could slow down a project. And, you know, so I think that's an important element of it.
Well, as John said, the main factors, the plate, what we call it, usually, if we have a plate that is smaller than 6,000 square feet, it's becoming more expensive by going in height. The cycle, keep in mind, New York, 2-day cycle, the same type of cycle is being maintained. If it's a 10,000, a 12,000 square feet, or a 3,000 square feet. So here is the cost the factor that it is. So the two items combined, I would say, small footprint and height makes relative higher cost. A narrow building, a small plate, and going high. So I would say that this is one of the main elements. Right, strength of concrete, 12,000 PSI, yes it is, but it's not as much of the fact that there is not enough room to develop a project in terms of square footage.
It's very simple. As the vertical elements of the building start containing the largest amount of material than the horizontal, you immediately have a building that is incredibly expensive. But
also the efficiency of the building, you know, for the point of view of the developer. Like in the case of 785, the footprint was only 3,000 square feet, and the core itself was 570. So you have an 80% efficiency, which is not what
Ideal.
most developers are looking for. But you know, it's the nature of the.
You're dealing in New York also with the location of the site and the fact that if you're dealing with an infill site as opposed to a corner site, you're going to have significant logistical issues in terms of where you can park, what kind of traffic lanes you can take, and just getting to and from the site. In addition to just loading on the site, it's where can you put hoist, how can you move materials.
Speaking of developers, is Jay Eisenstadt here?
Yeah,
He is. Okay, here, take my microphone. The developer is 785. Jay Eisenstadt.
Use this thing. Well, Veronica, right? I'm saying that?
Right.
Correct. Well, this is my first development in the city. Well, hopefully not the last. We're doing another one on 34th Street also. It's a huge site, 50 by 100. I don't know what to do with the space. You know, I'm usually used to 16 feet, you know, or 23 feet. Ismail and Israel did a great job, but, you know, just swinging the crane over neighboring buildings is something you don't think about. I have a train running under my building as well, the 8th Avenue line. So you have acoustical problems. We had like 15 engineers, different acoustical lighting, vibration, wind tunnel tests. We did inclusionary housing. We bought 428 tax abatements. We didn't even discuss, you know, the difference with that and what's going on now. Cantilever, which is another structural issue, as well as dealing with 5 different air right sites that we purchased. One of them was in a state which was fighting. We were the solution. So we helped family planning as well. So, you know, we wouldn't have gotten it if we wouldn't have solved their problem. So we really have come across a lot of different hurdles, which for our first project, I think, you know, it's going okay. Now I just have to get people to move in. Thank you.
Questions from the audience? If you shout out, or I guess there is a mic, but I mean, you could shout out. Cantor speaking of.
What is the incremental cost of the curtain wall when you have a ratio like that? You've got all perimeter and no footprint.
I don't think it makes a big difference on that.
I would agree with that. I would agree with that. I think if you want to compare different, you know, countries, I think it was mentioned before, you know, comparing Hong Kong to New York, there's different seismic, which has an impact. There's maybe stronger winds there, you know, so you'll have that issue. But I found that the price of the exterior wall didn't vary very much. Of course, in the triplex unit that has a 2-story high living room, yeah, that wall is definitely reinforced. It will definitely cost more than the typical wall. But you know, I think we all have the experience.
Does the wall cost you more per square foot in terms of contact area versus usable floor area?
Yeah, sure. If you've got a smaller footprint, that's true of any shape. Even if you know, I think the shape is the issue there. You could have a 12,000 square foot floor plate, but if the shape is not an efficient, compact shape, you're going to still have a high ratio of perimeter wall.
Yeah, but Erwin, that really goes for everything in the building, because take a regular building and you can figure out a concrete building that the average thickness of the building, when you add columns and everything and shear walls, may come to 12 inches or something like that. When you take the average thickness on a building like that, you're really coming very close to the 18 inches.
Yeah.
So every element of the building, obviously, per square foot is more expensive. That's why the building per square foot are more expensive.
Oh my God, Hardy Nussbaum is here.
Would the developers comment on why they built these buildings in spite of their incredible cost? Part of the answer is location, as Carol mentioned, but there must be other factors. Did you address that?
Well, we build them because it's hard to find other sites. You know, I mean, that's really the basic factor. It's, if you had other alternatives that were easier sites, the developer's always going to pick the easiest path, you know, to success. So we build them because they're in locations that we like, and we think that it meets the demand.
I'll concur, but we really thought we were going to get the corner side as well, and it just didn't work out. Really, originally it was supposed to be a 29-story building. Then we decided to get a little crazy, and we bought the surrounding air rights to protect our views and to get 3 sides of legal light and air, which is very important in an infill location. You know, you want to make sure you have windows and, you know, light and air going to all the bedrooms. So basically, the height really came on after the design was completed, and we redesigned again to go from 29 to 43 stories. Plus, the cost per foot by purchasing the air rights, you know, was less than $180 a foot, which in 2005 was a good number, you know, but $150 a foot. Right now, I don't know, but let's hope it gets back there one day. But that's really the economics of the deal. So although, as Ismail stated, the efficiency isn't that great, but the economics of this deal was really driven by the fact that the land was sold by a family that owned it for over 50 years and wasn't a developer. So that really played into the decision-making of doing this in the first place.
Maybe 2 more questions, Gideon?
Well, well, I thought we did.
Why?
Uh,
He wants
why
to
do
know
we do-
why
we-
you wanna
why did
break
we
up.
do it? Well,
He's asking why you want to break it up.
I think because we didn't want them to look like the towers of San Gimignano. I think we wanted them to have a distinctive. We wanted each of these elements of this tower to read distinctly different from one another and give it a variety. I mean, to tell you the truth, for me it was a feeling like I was taking three buildings and I was putting them together and giving this incredible compressed version of Manhattan, you know, on a site, on one site, and that to me is that was the interest, is to see this interplay of these three elements, and they were completely different from one another in a sense. You know, one sweeping with views, you know, horizontal banding to the north, the vertical kind of tower treatment, you know, and not shying away from the idea that, oh my God, I've got 50 feet and I'm going up 600. What do? Bring those lines right down to the ground, you know. So you know, make it soar, and then have the core of the building really be the kind of the strong punched kind of backbone for the building. So those were the kinds of, you know, things that were running through our heads when we were doing it, when we were designing.
I like the San Gimignano analogy. You know, I think we were, we sort of embraced that. You know, we
Yeah.
wanted our building, in contrast, to have that, you know, simplicity, you know, and strength just from the fact that it was 621 feet tall. You know, the program led us to create those balconies that, you know, where we cut into the form. But the interesting thing about glass is that it does give that monolithic look. You know, it's not a punched opening. It's not that punched window type of design. It gives you that monolithic feel to it, and on that site, you know, we like to also sometimes have contrast. You know, there's so many beautiful buildings in that area. They're very rich in texture, and that's great. But here, to contrast that with something that plays with the color, the simplicity, but plays with the color is very, very important. And when it was a rendering that we showed, the sun, that western sun hitting that glass, the west side of the building, it actually works. It does do that. It portrays itself as a kind of a monolithic form, and it's illuminated by the light, which then gets transformed as the sun goes down even further.
I just wanted to kind of pick up on what you were saying about, you know, for Sky High, I would have loved to have done the one Madison Park, and just to play with that as glass elements, as these wonderful massing elements. But we accepted, in our case for Sky House, you accept a palette, you know, and brick is a very rich material, and it kind of comes with its own rules architecturally, and so you play with those rules, and that's what we did. We basically decided we were going to play with the palette we had and play within the rules that we were given. So.
In terms of 785, we also tried to eliminate the monolithic look, and we have the cantilever. The cantilever became as an appendage to the actual massing. So having that, what I thought is that to make it even more dynamic by having the balconies being cascaded rather than just being straight down. And I was looking for a dynamic look, and I think is what we try to do.
But, go ahead.
You said that the acceleration of these buildings are not mandated by code, or the dampening of the acceleration are not mandated by code. So does that mean that different engineers will use different criteria? And if so, as a buyer, how does one know to go into a sort of a stiffer building than another?
Okay,
Well,
there are no written codes. However, there were all kinds of research that have been done through the years. And there are particular numbers that
there are recommendations.
that
Okay.
we know that these numbers that make the people living, and it's only a section, only a percentage, small percentage, and a particular age and a particular genre, that they feel the movements. Now, Also the timing, how often you feel it. Usually it's used 1 in 10 years. That's the maximum acceleration, or once a year with a smaller number. And the acceleration, since you asked the question, it's measured in milli-g. That is the weight, the g, 32.2 feet per second squared. That the natural acceleration of a free body falling. So that there are these studies and research that are going continuously, and we know that the other buildings have been built with the same criteria, and there are no complaints, and therefore we try to give to the public, in particular in condominium buildings where they are very expensive. So we want to be within the particular level as other high-quality buildings are being built.
That's why we recommend recessed lighting, no chandeliers, really.
Yeah. There is,
Well, we have solutions for the chandeliers.
to expand on your questions. That problem, that philosophy just made a change on the seismic design of buildings where now they have this performance design. And what it really is that it comes a point into the whole architecture and engineering and what to do and what not to do is that the developer is going to be asked, well, what do you want your building to, how you want the building to perform after an earthquake? Because they are different, they're actually 4 different categories. We are, it's not a secret, so neither a patent is going to come out of it. We are studying, because you saw one of the buildings had a tube mass damper because otherwise there was no way to controlling the acceleration like we put a tube mass damper in top of the Trump building in front of the United Nations. But now the idea that we have been working together with one of the wind tunnel people, wind tunnel companies, is at one point you stop, keep making these larger and larger and larger shear walls and just pay for a tube mass damper. In other words, the structure is going to be lighter. And we're not talking about buildings of this height. This could very well happen in a building of 30 or 35 stories. So you say, well, how well a damper is going to work to control this acceleration so we can reduce a little bit this imposition of the wind system with the shear walls and with all of these link beams and all of that create problems for the mechanical engineer and for everybody. But that, as we are looking at that, is going to end up also being a little bit of on the, if it ever happens, because it has to get to a code, it's going to be an issue that an owner is going to be told by me or by Sylvian, listen, this is what the recommendations are. You should be between this many milli-Gs and this many milli-Gs. Where you want to be? You want to be at the far end? That's one. Number two, how much trust are you going to put in a volume of water moving in top of your building? They have worked very well, and not the slush dampers work very well, but you know, you just mentioned, I'm going to buy a condominium. You're going to ask the owner if he has a slush damper or not?
We don't.
We're almost at the end of the evening, but if I might take the prerogative to ask the last question, because we've certainly talked about the technical aspects of tallness. We've discussed the aesthetics and the various options, and we've talked about the economics. And if we think back to the definition of Cass Gilbert of a skyscraper is a machine that makes the land pay, he said. Economics are really at the base of it. So given our total obsession at the moment with the current economic crisis, I wonder if you think that as has been predicted before, the death of the skyscraper, we've seen the last of these tall, slender towers, or if they remain a viable option from the development point of view in New York, just as we've clearly seen that they demonstrate an aesthetic and engineering exceptionalism that works that works practically. Does it work as an economic blueprint going forward?
Well, I think it's very hard to respond to that without being in the context of where we are today, and we are in extraordinary times. And frankly, I think these towers it's going to be a very long time before we see many of them again, because most of them, we have basically a capital markets shutdown, and there is no capital available for construction. There is zero capital available for condominium construction, and most of these tall, slender towers have been developed as condominiums. So there are two things that are going to impact when these towers will be built again, and that is capital availability and the price of the land, because land is and cost of construction. But I think it's many years. Many.
I agree. Although the cost of construction supposedly has come down a bit, but you can finance that lower cost of construction anyhow, so it doesn't make a difference. And land has come down, but again, there's no money to buy the land. So I guess it's a little bit, you're stuck. And the condo market. Also, one thing we haven't discussed is the rental market. And a lot of condominiums are backstopped by the rental market, which now is also decreasing in the rental rates. So even if it does come back, the rental market has to come up as well to support the backup analysis that the bank wants to fall back on. So you're really missing all the elements except perhaps the construction cost is decreasing, but
So you need a damper.
a damper, I don't know,
Financial
I get seasick,
Financial
Okay,
damper.
well, help me to thank these really exceptional panelists for this evening.